we start to talk about operations with scientific notation. So add, subtract, and multiply and divide. And we have similar rules for addition and subtraction. So when adding or subtracting these quantities, we express in scientific notation. They have to have the same power of 10 to do that. And we have 10 to the x here as our arbitrary thing. But really, it has to have the same exponent or the same power. So you can see here in our example, we've got 8.67 times 10 to the 6 and 3.2 times 10 to the 6. And so we add our numbers together, 8.67 and 3.2, gives us 11.9, and then notice our 6 stays there. Now, 11.9 isn't in proper scientific notation. That decimal is actually just 1 over again. So we end up with 1.19 times 10 to the 7. So it's great for addition and subtraction when the exponents are the same. In the next part, here, as you can kind of see, the exponents now are different. So how can we make them the same is the next question if we wanted to be able to subtract in this case. So we have two options here. I can either try to make the 5 into a 4, or I can make the 4 into a 5. Both ways are right. I'm just going to run through one way by changing the 4 into the 5, but feel free to do whichever way makes sense for you. So I have 4.23 times 10 to the 5. Okay, 4.23 times 10 to the 5. And we're going to subtract. Now, if I had that 1.5 times 10 to the 4, that 4 means that this decimal is going to jump to the right 4 places. So if I actually moved it one spot to the left, that would make it 0.15 times 10 to the 5. It's not in proper scientific notation, but it will help with this problem because now they're the same power. So if I went and subtracted it, 4.23 minus 0.15, then I get 4.08. And because my exponents are the same with addition questions, they stay the same, 4.08 times 10 to the 5. And so that becomes my answer. So addition and subtraction have to be the same power. And if they're not, we can actually make them the same power and then use that operation afterward. So multiplication and division, I actually find this one a little bit easier to do because really the steps are pretty laid out pretty straightforward. So in this case, it says when we multiply and divide, the quantities need to be expressed with different powers, or they can be expressed with different powers. And when we multiply, we actually add them. So we start off and multiply the numbers together. 7.45 and 8.256 gives us 61.5. And then after that, we take a look at our exponents. It doesn't really matter with them, 6 and 3, but when you multiply exponents, they add. So that's the reason why that becomes a 9. And then again, it's not in proper scientific notation. That decimal actually has to come one spot over. So when it moves one spot over, it's going to turn into a 10 because that times 9 really means move to the right 9 places. So if I move it one spot to the left, it's got to go up one more. If I look at the division problem that's below, I run into the exact same thing. 9.7608 divided by 4.621 is going to give us 2.112. Now, after that, when I divide exponents, remember they subtract. So negative 9, right, negative 9 divided by, which is going to be subtract from powers, subtract 4 gives me negative 13. And so that's the reason why the 13 shows up over here. Okay, it's already in proper scientific notation, so that problem is done. So the next part, if you're looking for a little bit of extra practice with this stuff, we can try the following out. And again, pause whenever you can to be able to take a look at it. and we can kind of get ready to go when you're ready. Okay, so with these questions, we'll kind of do some spot ones here and allow you a little bit of time as well to kind of run through them. So for the first one, if we take a look, I've got 4 times 10 to the 8 and 3 times 10 to the 8. So 4 and 3 make our 7. And then I've got my times 10 to the 8. Because I'm adding, the exponents stay the same, and it's in meters. In the next one, I've got 6.2 and minus the 2.8. And because the exponents are the same, I can just subtract them, and I get 3.4 times 10 to the negative 3. Okay, so both of these are done the same way. Down below we have 2 separate ones in C and D where the exponents are a little bit different. So again, that 5 means that it's going to move to the right 5 places in C. And so if I move it to the left, then it becomes 0.3 times 10 to the 6. So really, then I'd have 4.3 times 10 to the 6 meters by adding them together. Likewise, in the next one, I can subtract. So keep in mind now, negative 7, the 3 times 10 to the negative 7, that value is going to want to move to the left 7 places. So it's going to start here and it's going to head in that direction 7 places, which means if I moved it just once, I'm going to get negative 6. So now I'm doing 4 minus 0.3, and I'm getting 3.7 times 10 to the negative 6 kilograms. In the next case, I'm in different units. And so it really doesn't matter which unit that we answer in, whichever one's more convenient to go through. In this case, the 4.1 is going to give me a really small value if I convert to kilometers. So if I started at 1.5468 and I wanted to then move that into meters, that's going to give me at least a couple of numbers that I can add together. So I could run through my division for the metric system chart that I showed you earlier, or we could understand that if we go from kilometers to meters, I need to multiply by 1,000. So I'm going to have 1,546.8, and I need to add 4.1 to that value. And so I'm going to get 1,550.9, and remembering that we changed everything into meters. Then becomes 1, 2, 3. And so by moving it over, I get 0.0061, 0.0061 milligrams. Oh, and I said milligrams, sorry, grams I mean, because now we're out of the milligrams. Now, in the first one, I've got 2.31 times 10 to the negative 2. That really just means move the decimal 2 spots to the left. So I'll have 0.0231 grams. So I just add the two of these together, 0.0231, and I get 0.0292 grams. I could multiply that back out by 1,000 if I wanted, and I could get 29.2 milligrams, or I could put this in scientific notation and say that I have 2.92 times 10 to the negative 2. And in that case, it would still be in grams. Okay, for the next one, in this case, we're multiplying. So 3 times 2 gives me my 6. And then I add the exponents together, times 10 to the 9 meters, and then because it's meters times meters, meters squared. Next one, 2 times 4 gives me 8. And then I've got times 10, now minus 5, plus 9. I'm going to get my positive 4 times 10 to the 4, again, meters squared. The next part, in I, 4 times 5 gives me 20, and it's 20 times 10 to the 14. So 20 times 10 to the 14. Now that's not in proper scientific notation because the decimal has to go after the first non-zero digit. So really, this is then going to turn to 2.0 times 10. Now, that would be 14 jumps to the right, 1 jump to the left would make that 15. If I look at my units here, they are different in this case. So it's a kilogram meter. Kilogram meter. They just go beside each other. When I divide, I've got 8 divided by 2 gives me 4, and 6 subtract 3 because it's a division is times 10 to the 3. And I've got meters over seconds. And the last one in K, 8 divided by 2 gives me 4 times 10, and then I've got 6 divided by 2, which is 6 subtract 2 from the exponent power rule. 6 subtract a negative 2 is like 6 plus 2, that's 8, and so I've got kilograms over seconds. Right? Hopefully that was helpful to understand scientific notation and order of operations. So if you're looking for a little bit of extra practice, then I would recommend that we try out the Intro to Measurement Part 1 worksheet. There'll be a link here, or it'll be attached to the video for you to be able to open and try it out. Thank you very much.